Okay.
All right, everybody. So in this video, we are going to talk about complex numbers. So I have like a secondary title. I kind of specify and break things down a little bit more, talking about imaginary, real, and complex numbers. So imaginary and real are clearly two separate groups, right? You have your real friends and your imaginary friends, but we also have real numbers and we have imaginary numbers. A real number is basically one of the numbers you already know, okay? If you haven't learned imaginary numbers yet, every number you've learned is real. 0 is a real number. 1, 1.5, 3 over 2, negative 10, pi, square root of 2. Those are all real numbers, all right? There's many different sets of them, subsets of each other. And then there's imaginary. So let's kind of show you an example where you might say you have real solutions or two real solutions and you have no real solutions. For example, right here, these warm-up examples, solving for x. X squared equals 4. In order to solve for x, you would take the square root of both sides because that's the inverse of squaring. But when you take a square root yourself, we put plus minus out front. A square root is asking you what thing times itself equals that thing inside. So here the square and the square root are crossing out, gone, equals positive and negative. What number times itself is 4? 2. So those are our answers, and we have two real solutions. Now let's contrast that with this example over here. If we try to do the same thing, right? We go in, we're like, all right, I'm going to do the same thing. Take my little square root. Good, great, okay. Plus, minus, but what number times itself gives you negative 9? Nothing, right? A negative times a negative will be positive. A positive times a positive will be positive. There's no way we could get a negative answer by multiplying something by itself. So that means no real solution. There's no real solution, but does that mean no solution? That's not what we said. We said there's no real solution. But what do we have? We actually have two imaginary, and it's actually a math term, it's not like I'm being crazy, two imaginary solutions. So let's take a couple more notes and talk about the imaginary unit I. We use the letter I for imaginary, kind of makes sense. So I want you to kind of picture a clock in a way. If you have a clock, we number a regular circle clock, right? We number 1 through 12, 0 through 12. Good, yeah. 1 through 12 around the clock, and we pass those numbers twice in a day and then again every day. So it's not like I need to throw away my clock after a day and make a new clock. You know, we can use the same clock every 12 hours. It's good again, you know, repeat, repeat, repeat. So when we talk about imaginary numbers, you're going to kind of picture it on a clock or on a wheel where the answers are going to repeat every 4. There's 4 units. So it goes 1, 2, 3, 4, repeat. 1, 2, 3, 4, repeat. And round and round and round we go. Kind of like a pattern. And we just put it on a wheel or a circle or a clock because there's like some tricks we can use to help us remember stuff, okay? So first things first. We're just going to write down what this is called. So this is called the imaginary, it's a pretty short section, the imaginary unit. I'm going to put little quotes. Now, when you draw your eyes in this section, I would say put the little curly tail on it and also a heavy dark dot on top because we're going to do a lot of stuff with I and with the number 1. So maybe you want to put like the little hat and shoes on your 1. So what do I mean? Well, I, try to make it as aggressively an I as possible, is equal to the square root. Make sure your square root covers the roof of the whole thing that we're trying to put under there, okay? And I'm trying to make it so my hook is pretty clear. The square root of negative 1. And usually I put a little hat on my 1s, but sometimes it starts to look like a 7 when I'm a little too aggressive. So let's put shoes on it as well. All right, just so we don't get mixed up. So we just say, like, anytime there's a negative involved, because -1 being multiplied is really just going to give you the negative, you know? So the square root of -1, the answer is I. We would never leave an answer like that. You would instead write your answer like that. But, couple side things. For starters, the square root of -4, you would just put 2i. The square root of -9, you would just put 3i. If you had x squared equals, so I'm going to put little bullet points. So that was the first one, second one, now I'm doing this third one. If you were solving x squared equals -16, then we go in and we take the square root of both sides. We get x equals, if you take the square root, we put plus minus. And now the square root of a -16. Well, the negative is that -1. This negative represents -1. This negative represented -1. The negative in the square root is what turned into the I, and then the square root of 4 was just 2. The negative inside the square root became I. The square root of 9 was just 3. So here, though, I'm taking a square root. It wasn't given to me on the problem. If I'm taking it, I need plus minus. The negative gives me the square root of -1, essentially. That's the I. And then the square root of 16 is 4. So, you know, to solve that next step for this problem, we get those answers right there. So that's one aspect of it. And those are all imaginary numbers, all imaginary answers. Now, how else can this be involved? You're going to see that we might end up seeing it with exponents, like I squared. Now, think of it this way. Pretend that you squared this side, and now you have to square this side. I squared equals what? I squared. Done. Cool. Done. Equals. What happens when you square a square root? We just saw it on the last page of example. When you square and you have a square root, those are inverse operations. Cross them out. That means I squared equals -1. But I'm going to throw a little detail in here as well. You will not ever leave I in your problem with an exponent other than an invisible one. Sad face. Here, the left side is good. We like that. Here, we don't like this. -1, we do like. That's good. So here, I is better than the square root of a negative. Next, -1 is better than I squared. You will memorize the crap out of this. I'll ask my pre-calc kids, I'll say, what does I squared equal? And they haven't done it in how long? They're going to be like, -1. They'll know because you use it a lot. We haven't used it in a long while, but they know it. I to the third equals, so this is what I mean. You're going to see a lot of ones and I's, so you want to make sure you really make those dots. This is an I, you know. Now, I to the third is really the same as I times I squared. So that means that I to the third is really the same as this times this. But let's use the happy face things. So it's really the same as negative times I. So it's really the same as -I. Again, I squared is negative. I is just I. I, just on the side to show a little bit more, by itself is I to the first power times I to the second. The rule for properties of exponents is you add the powers, and that's I to the third. Sorry, it's a little squished. I to the third right there. And I squared, I just swapped that out for the -1, and that's why it became -I. Okay? You could just memorize it, but so which one's bad? We don't want I with an exponent, so we don't like that. Anytime it pops up, what are we going to change it into? -I. Next one is I to the fourth. Now I said that the pattern had 4 things in it, so after I to the fourth, just going to be straight up with you, they start repeating. I to the fifth will be the same as this, 6th, 7th, 8th, 9th, 10th, 11th, 12th, so on and so forth. I to the fourth, well, that's the same as I squared. That will be I to the fourth. So what's -1 in parentheses squared? That means it's -1 times -1. And what does that equal? 1. Obviously, I mean, which side of the equal sign do we like better? Do we like a 1 better or I to the fourth power better? Well, I hope we like the 1 better. That is much, much better. So I'll explain a little further in class and whatever people might need. But I to the fifth, it's pretty easy to understand if you just like focus for a second here. I to the fifth is going to be the same as I to the fourth times I. So it's 1 times I, so it's I. I to the sixth is I to the fourth times I to the second, so it's 1 times that. You know, like, so you're just going to have that 1 thrown back in over and over and over again. So since this pattern continues, what could we do? I rhymes with Y, okay? Remembering this? I rhymes with I. So I'm going to make this, Dallas, you got to stop, bud. I'm going to make this my I axis, so instead of Y, okay? I, positive up there, negative I down here. And then my X axis, well, that's like the ground that we walk on. That's the real world, right? We walk on the ground. Maybe our imaginary friends, they fly into the sky or they can go underground. Imaginary, they're everywhere. They don't have to walk on the ground. So here I'm going to put 1, and I'm going to put over here -1, just like the x-axis. You know, we have positive x, positive y, negative y. Now, if you look at these numbers carefully, I'll just color code them as quickly as I can over here. You just grab some highlighters. So here, this smiley face is smiling at this guy right over here, and it's right there. That's where we start on, you gotta stop, buddy, okay? You gotta stop. Then I to the second, smiley face is smiling at -1. That's gonna be over here. Then, this one, smiley face, what's it smiling at? This guy right over here, stop it. And that's down over here. And last but not least, this one is right here and right here. So essentially, once you know where the I's and 1's and positives and negatives go, which you could definitely memorize, we're going to start basically here, and then you go round and round and round until you go where you need to go. So I to the first, I to the second, I to the third, I to the fourth, fifth, sixth, seventh, eighth, 9, 10, 11, 12. So if you need I to the 30th power, the cheap way is to remember that your multiples of 4 for the powers will land here. Multiples of 4 as the power land here. And then you kind of save a little bit of time. See, it looks like a 4 because I know I do this to my ones all the time. And then you could kind of move a lot faster after that and kind of skip ahead a bit. So if you needed to know I to the 83rd power, and someone was like, simplify this for me. I to the 83rd power. And you're like, what? I have to count around to 83? Not really. 80 is a multiple of 4 because it's 4 times 20. 81st, 2nd, 3rd. So 83rd will be here. So what does it equal? -I. And you're done. So these highlighted pieces are going to be the answers to those particular parts. So this is an introduction to the imaginary unit I. We did this one, a lot of people will do something like this and they call it like the I chart, you know, when you get your vision checked. But I kind of like this guy better because I think it's easier to remember I, -I, 1 and -1. You start at the top. Like, just like you start at the top when you make an I, you know? You start here, bloop. Well, maybe that's the last thing you normally do, but let's pretend you don't. And you go round and round and round till you find what you're looking for. And then we could just kind of throw in a couple little things and then you're going to be good for today. Now, not only does this help you with the I values with powers bigger than 4, but it also helps you because we actually have something called the complex plane. It's actually exactly what I drew before. and you can plot numbers on there. So there's two things that we can do. Actually, I should put the complex plane. So it's just like the XY plane. I is still there. And this is going to be, let's call this real, and we'll call this imaginary. So you have a real axis and an imaginary axis. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so if I said for you to plot 2 plus 3i, all you have to do, 2 in the real direction, 3 in the imaginary, put a dot. That's it. It's not a line. So you go over 1, 2 in the real, then you go 1, 2, 3i in the imaginary, and you put a dot, and I'm going to label that dot A. Done. That's it. Literally finished. That's all it takes. B, I'll do another type. So what if we had to plot negative 4i plus 1. Careful, because you might want to write it in the form, they call it 𝑎+𝑏𝑖, like this for the style. That's a complex number now. Why is this complex? Is where the complex word comes from. It's complicated when you're trying to live in a world with real friends and imaginary friends. When you have them in one place, things are complicated, okay? You have the imaginary part, you have the real part. So the real part is obviously the one that doesn't have an I. The imaginary part is the part that does. So how do I plot this? I'm going to go 1 unit in the real direction, negative 4i, so 1, 2, 3, 4, negative 4i in the imaginary. There we go. Point B. Done. Easiest thing you ever did in your life. If you had to plot like negative 2i, that's just the same as 0 minus 2i. And you would go right there, and that'd be point C. You just don't have another value that way. And the other thing that they could ask you to find here is something like D down over here. I'll make it its own little special part. And that is the absolute value of, let's say, negative 4 plus 3i. Absolute value. Now, while I plot the number first, what does absolute value mean? There's negative 4. There was 3i. There's point D. Absolute value is distance from 0. So double quotes. I shouldn't have done it the way I did, but whatever. This will be a single. I think it's supposed to be on the inside. So distance from 0. And instead of 0, we are going to look at that as like the origin. How far is this point from this origin? Guess what you're going to do to figure that out? Everyone's favorite theorem. You guessed it. Pythagorean theorem. Don't worry, it's not that hard. How long is this side? 4. How do I know? I counted 4 units to go that way. How long is this side? 3. How do I know? I counted 3i up. So you just do 4 squared plus 3 squared, Pythagorean theorem, right? A squared plus b squared. It's even a and b in that equation, right? Equals c squared. That's what we're solving for, the hypotenuse. Okay, this is all going for part D. I'm just going to squeeze that all underneath here. Then we have 16 plus 9 is c squared. And then that's 25. Take the square root of both sides. C equals plus minus 5. But if we're looking for a distance, absolute value, we want to know it in positive sense. That's 5. So that means the answer to this absolute value of that thing means how far is that point from the origin? The answer, 5. That's it. If I ask for the absolute value of 2i, how far is it from the origin? 2. I don't really have to do anything. Anything else? You make a triangle, bust out Pythagorean theorem. When you add and subtract complex numbers, there's not really much to it. So I'll just show you a couple quick examples. 2 plus 3i plus 4 plus 6i, and let's actually, I'll make that a negative, whatever. So 2 plus negative 4, that's negative 2. 3i plus positive 6i, 9i. Guess what? You're done. That's literally it. What about subtract? All you have to remember is distribute the negatives. So what if I had 2 plus 3i again? Minus, negative 4 plus 6i. All you do is distribute the negative and you treat it like an x. It's no big deal. So 2 plus 3i minus becomes plus 4, but minus positive, so it's minus 6i. And again, combine like terms. 2 and 4 is 6. 3i minus 6i is negative 3i. That's literally it. You're done. Multiply. Here you're going to have one extra step. We're almost done, home stretch. One extra step. So what if we had 2 plus 3i times negative 4 plus 6i? They like also to put parentheses on the SAT around adding when you don't really need it because they want you to accidentally FOIL. Watch out. FOIL. First times first, negative 8. Outer, 2 times 6i. Treat it like an x, so it's just plus 12i. Almost done with all this stuff, okay? 3i and negative 4 is negative 12i. Ooh, that's coincidence. They're going to actually eliminate. That doesn't always happen. And then 3i and 6i, that's going to be plus 18i squared. This was, I didn't do that on purpose. It just, that happens sometimes. Negative 8. But what did we say? We don't leave I squared in the answer. Do you remember what I squared equals without looking? Think about it. Plus 18 times is negative 1. So if you remembered, give yourself a high five. Now that's negative 8, in this case minus 18, and that's negative 26. But these two terms don't always eliminate. That was just pure coincidence because they truly are. There's really a conjugate hidden under there. If you think about it, if you factor out a 2, then you have 3i plus 2 and 3i minus 2. That's why that happened. And the last thing we have, speaking of conjugates, the last thing we have is division, and that's the last one I'm going to do for today. And well, what half of the last thing. So if I give a numerator, let's do, I'm just going to keep using these because that's what I was doing. Negative 4 plus 6i is my numerator, and my denominator will be the 2 plus 3i. Since I is really the square root of a negative number, it's a radical, and we're not allowed to have a square root in the denominator. We have to rationalize this. You're truly rationalizing. And the way you rationalize, if you remember from even geometry, you might have done examples like this. The way you rationalize when you have a plus or minus sign in your denominator with the radical is you multiply the numerator and denominator by the conjugate of the denominator, which is 2 minus 3i. 2 minus 3i. You did conjugates when you did factoring. Then all we do, safety first, put on those parentheses like a life jacket or helmet, and then FOIL top, FOIL bottom. First times first on top, you get negative 8. No, I'm moving fast. Slow me down if you need me to. Negative 4 and negative 3i is plus 12i. 6i and 2 is plus another 12i. 6i and negative 3i is minus 18i squared. Just to cut that off, you know. Over, first is 4. Outer is negative 6i. Inner is positive 6i. Eliminated. Gone. They crossed out. That's the point. That's why we use conjugates. And then on bottom, you get negative 9i squared. Don't forget, I squared is going to come up the most. And what does I squared equal? Negative 1. So, cleaning this up, finishing it up. 12i and 12i was 24i. Negative 8. I'm just going to rewrite it in different order. Sorry, I turned it around. But I still have minus 18 times negative 1, because I squared is negative 1. But then that's my numerator. That will become 24i. There's the minus 8, but now that's going to become plus 18. Negative 8 plus 18 is 10. So I guess I'll put it in front again. I know I'm confusing. 10 plus 24i. Okay, that looks pretty sweet. Bottom, 4 minus 9 times negative 1, which is 4 plus 9, which is 13. The last thing, only thing they might do extra to simplify is do 10 over 13. So you see your a plus 24 over 13 I. So it's like a plus or minus bi. And then you're done. So we don't have i's in the denominator ever. Not allowed to have them. We get rid of them. And we don't have I to a power in our answer other than I to the first power. Those are the rules basically. So what do we just do? We add, we subtracted, we did addition, we did subtraction, we did multiplication and division with imaginary numbers. It's not that bad. Box that. Okay. We talked about the little wheel over here to help us remember all 4 of them and the pattern that goes round and round we go. We saw some simple examples using it. We talked about the complex plane and how we could plot points and how we could find the absolute value of them, which truly means distance from 0, and we bust out Pythagorean theorem. And the only other thing that you might see is, for example, if you were doing quadratic formula and you ended up with a negative under your radical, how do you handle that? Well, I'm going to do one quickly for you to copy into your notes, but if you have x squared, which is really a 1x squared, plus 5x plus 25 equals 0 and you were solving, all right? A equals 1, B equals 5, and C equals 25. We're solving that. It doesn't factor, so we're going to use the quadratic. Well, let's do this to solve, because I don't want to mess up names. Solve a quadratic equation. So quadratic formula to solve a quadratic equation. So here's my equation. Now the formula, we have a, b, and c ready to go, was x equals negative b plus and minus the square root b squared minus 4ac all over 2a. I promise we're going to fill this in and we're going to get a negative under here. Negative b is negative 5 plus and minus the square root. B squared is 5 squared minus 4ac all over 2 times 1. Scooping around to continue. X equals negative 5 plus minus the square root. 5 squared is 25 minus 4 times 1 times 25, 100. 2 times 1 is 2. X equals negative 5 plus minus the square root of negative 75 over 2. Simplify radicals. 75 is really 25 times 3, and 25, it's a perfect square because it's 5 times 5. So I got a perfect square. 5 will come out of the square root. A 3 will stay inside. You should remember that even from geometry. If you need more help with that, I'll help at a different time. We're just setting up this example. So we have negative 5 plus minus. That 5 happens to come out. It does not combine with that 5 because it's attached to the square root 3 still, all over 2. However, the main attraction, it wasn't 75, it was negative 75. And what's the square root of a negative number, or the square root of negative 1? Bam, I. That's the only difference. So grabbing my highlighter, highlighting the most important detail here. We got a negative under our radical. We do everything more or less the same way, except we'll end up with an I in front of the radical. Amazing. That's it. that is it. And if you wanted to separate it like the other stuff, you could write it as -5/2, kind of pretzel style, plus and minus. You could even look at it as like 5√3/2i. So you see the 𝑎+𝑏𝑖 style, but most people just leave it like this. Okay? So I know this was like a quick, powerful, fast review in 30 minutes of everything, but I hope that it stuck. I hope that you can work on memorizing this. I hope that you will be able to do the examples that I assign, because what am I going to give you? Well, I'll probably give you 2 examples like this. I will probably give you some stuff to memorize and work out like that. I will probably ask you to plot points on the plane, find absolute value. It's going to go in the same order. I'll ask you to add, to subtract, to multiply and divide, and to solve with quadratic formula and get a negative under the radical. There's other stuff that we could still do, but that's like the main gist of everything. So if you feel like, yeah, I could tackle these examples, put thumbs up. And if you're like, I have to watch this video again before I try to do an assignment by myself, go ahead and put a thumbs down. And maybe the second time you watch it, you'll change it to a thumbs up. We'll see. But I wish you luck, and I will see you next time.